Here's an example of multiplying in scientific notation. Here are the two numbers that we're multiplying, 3 times 10 to the 4th and 5.2 times 10 to the 7th. In order to multiply in scientific notation, you actually multiply the leading digit numbers and their decimal extensions together. So you multiply those together and you multiply the tens together. The reason you can do this is simply a bunch of numbers multiplied together, which means we can use associative and commutative property to rearrange it in a way that's convenient for us. Now 3 times 5.2 is 15.6, and when we're multiplying the tens together, we simply add the exponents, since all we're doing is counting how many tens we have. So we have 4 of them and 7 more of them, so we have 11 of them. So this gives us an answer of 15.6 times 10 to the 11th. However, this is not written in proper scientific notation form. So we would need to fix this answer, which means we can take the 15.6, write that in scientific notation, 1.56 times 10 to the 1st. And remember, that all was being multiplied by 10 to the 11th. So formally, when we do it this way, we get to now put the tens together. So we've essentially borrowed a 10, or the 15.6 has donated a 10 when turning itself into 1.56. So now we're going to get 1.56 times 10 to the 12th, and that's because the 15.6 is bigger than simply a number 1 through 9. However, many textbooks and many worksheets will not show you this next step, but I prefer that we use an approximation, which is a rule of thumb or a guideline that will allow us to decide how many significant digits we should have in our answer. Since our first number only had one significant digit and our second number had 2 significant digits, we get to keep the least amount of those. Since 1 is less than 2, we only get to keep 1 significant digit in our answer, which means what we should do is get an approximate answer here of 2, because 1.56 rounded to the leading digit, to the first digit, with only keeping 1 digit, is approximately 2. It's closer to 2 than it is to 1. So our answer would be 2 times 10 to the 12th. The reason for this can be complicated, but essentially what we're saying is we can't get a more accurate number from multiplying 2 inaccurate numbers together. So we keep the least number of significant digits, keeping our accuracy approximately the same. This is not a perfect system, but it is a rough guideline that we can use. So for a second example, we have these two numbers that we'll be multiplying together. Once again, this means we're going to do 4.19 times 3.1789. And once we sort out what that is, that will be times 10 to the 8th times 10 to the 15th, since we've rearranged it using associative and commutative properties again. 4.19 times 3.1789 is 13.319591. Thank goodness for calculators. And when we put all of our tens together, we get 10 to the 8 plus 15, or 23. So this now is a number we again need to fix, because we are not a digit in our leading digit. We're not a number between 1 and 9. We're 13. So we need to fix it. So once again, this is actually 1.3319591 times 10 to the 1st times 10 to the 23rd, and we put the tens together and we get 1.3319591 times 10 to the 24th. And of course, I've kept too many significant digits because our first number has 3 significant digits and our second number has 5 significant digits. So we get to keep 3 significant digits. So we're going to round this number to 3 digits. That's going to give us 1.33, and it stays there because the next digit is a 1, so we round down. So the answer is approximately 1.33 times 10 to the 24th. Here's one more example, this time in dividing by in scientific notation. So in this case, we really want to think of this number as 3.15 times 10 to the 15th divided by 7.2 times 10 to the 12th, and showing it explicitly as a fraction reminds us that this is a division problem, but still we can pair it off however we would like. So we're going to think about it as doing the fractions 3.15 over 7.2, getting an answer for that, and doing the fraction 10 to the 15th over 10 to the 12th. If we do each fraction and write it as a decimal, or write this as a decimal, this part right here gives us 0.4375, and our tens gives us 15 tens on the top, canceling with 12 tens on the bottom. That would leave 3 tens on the top, and so we're multiplying by 3 tens. Now once again we need to fix this answer, so writing our decimal version here in scientific notation, we're going to rewrite that as 4.375 times 10 to the negative 1, because we're dividing by 10 to get back to our original decimal, and that's all being multiplied by 10 to the third. So we can rewrite this as 4.375, putting our tens together. We have one 10 that we're dividing by and 3 tens that we're multiplying by, so that's going to leave us 2 tens that we're multiplying by, since the dividing 10 and one of the multiplying tens will cancel. And then of course we need to fix our significant digits. So our first original number had 3 significant digits, our second original number had 2 significant digits, so by our guideline we only get to keep 2 significant digits, which means this number should be approximately 4.4, since the next digit after 3 is a 7, so we round up. 4.4 times 10 squared. In other words, our answer is roughly 440 when dividing this very large number, 3.15 times 10 to the 15th, by another very large number, 7.2 times 10 to the 12th. What that tells us is roughly 440 of those 7.2 times 10 to the 12th fit into 3.15 times 10 to the 15th.